Okay, today we are going to the second part of the chapter 4 involving surds. And before we go into the surds, we have to know what is the meaning for rational and irrational numbers. Example, an irrational number is a real number that cannot be written as a simple fraction. Irrational means not rational. Like example 1.5. We can write it into 3 over 2. It's a simple fraction. So this is called rational number. Example for pi equals to 3.1459 and so on. It's an irrational number because we cannot write it into the simple fraction form. And then you may ask why the pi actually is 22 over 7, right? Why this one cannot become an irrational number? Afterward, I'm going to tell you why. And then we go through again. A rational number can be written as a ratio of two integers. Example for a simple fraction. 1.5 is rational because it can be written as 3 over 2. 7 is rational because it can be written as a 7 over 1, okay? 0.333 is a repeating. This one is called recurring number. Repeating or recurring numbers. It's also rational. Actually, 0.3333 is a 1 over 3. So these are all the rational number. And for the irrational number, some of the numbers cannot be written as a ratio of two integers. They are called irrational numbers. Example, pi is a famous irrational number. Pi equals to 3.1459 and so on and many more. We cannot write down a simple fraction that is equal to pi. And sometimes we can see from the question, they ask us to use the pi as 22 over 7. Actually, 22 over 7 is an approximate value of pi. Approximate means near the pi, 22 over 7. And 22 over 7, if we press the calculator, it will become 3.14285. It is not the actual pi, it's only an approximate value only. The actual pi is 3.14159 and so on. Actually totally different. So this pi is not the rational number. It is called irrational number. Another clue is that the decimal goes on forever without repeating. Means they are not recurring decimal places. So if recurring decimal places, recurring decimal numbers, it is rational number. It's not recurring, not repeating. This is irrational numbers. Okay, some of the famous irrational number. This one you can find from the Google. Pi, the Euro number E, the golden ratio, and the square root. This is most of the famous irrational numbers. Okay, now we go into surds. What is surds? When we can't simplify a number to remove a square root or a cube root and so on, then it is a surd. Example, square root of 2 cannot be simplified further. So this is a surd. Square root of 4 can be simplified to 2. So it is not a surd. Okay, have a look for some example. The first one, determine whether this is surd or not. The first number, square root of 2. Just now we have the example already. Square root of 2, simplify it, still square root of 2. As a decimal, 1.414 and so on. So this one is an irrational number. So this is a surd. Second one, square root of 3. Simplify, still square root of 3. And as a decimal, 1.732 and so on. So this is also another irrational number. So this one is can call as third. Square root of 4 simplify as 2. So this is not a third. Square root of 1 over 4 simplify it become 1 over 2. Then as a decimal 0.5, this is not a third. Cube root of 11. Still simplify it, we get it cube root of 11. So definitely this is a third. Cube root of 27. Simplify it become 3. As a decimal also 3. So this is not a third. This one square root of 5. As a decimal 1.2457, and the answer will be this is a third. So the third have a decimal which goes on forever without repeating and are irrational numbers. Okay, next part. How to convert a recurring decimal into a fraction. Okay, or you write it in the third form. Into a fraction, okay, can write it into the third form. Oh no, sorry. It's a converting a recurring decimal into a fraction. Example, 0.77 and so on, dot at the back here means recurring, repeat the number 7777 and so on. As a fraction in its lowest term, we write it in the lowest term. So we can try to use substitution. Legs. I just put any symbol in equals to 0.77. If I multiply the whole equation with 10, it will become 10n equals to 7.77 and so on. This is equation number 2. What happens if I have equation number 2 minus with equation number 1? So 10n minus n, I still have 9n. 7.777 minus 0.777, I left 7. So n equals to 7 over 9. Hence, we can write it as 0.77 actually equals to 7 over 9. If you don't believe, you can press your calculator to check the answer. Okay, not very difficult. For the second question, now this recurring number is a little bit different. 0.2777. So we have to make it become a recurring number. So I try to multiply the whole equation. Let's say legs. I still move n equals to 0.277. If 10n equals to 10n equals to 2.777 and so on. If I try to minus equation number 1 and equation number 2, actually, you minus it, you'll find that 2.777 minus 0.277 is 2.500 and so on. This one is not complete. It's not complete because we still have the decimal here. So I try to make it 100n. Multiply with 100. They will become 27.777. Now we try to minus 3 minus 2. Equation number 3 minus with equation number 2. What happened? 27.777 minus 2.777. And then you can see that this one becomes 0. This one becomes 25. So 90n equals to 25 and n equals to 25 over 90. It's not simplified yet. You can make it into the simplest fraction where you can divide the whole equation with 5. Okay, a whole fraction with 5. It will become 5, 5, 25, 5, 1, 40 or 515 40 58 40. The answer is 5 over 18. So the important part is here. After we try to minus equation number 1 and number 2, they must make it into the integer. Okay, integer means whole number. Like this decimal, we still cannot solve it. We must try to multiply it with 10 and 10 and 10, means that 10, 100, 1000, 10,000 and so on, so that we can get the equation become n. For the next question, 0.0855 as a fraction in the lowest term, and 0.0855 still start with less, n equals to 0.0855. So I try to multiply it with 100, become 100n equals to 8.55, and for 1000n it will become 85.55. Remember, I want to make it become an integer after the two equation have been deducted. Okay, so now we have equation 3 minus with equation number 2, where 1000 multiplied with 100, I still have 900n, and 85.55 minus with 8.55, I still have 73. So n equals to 73 over 900. This is already in the simplest form. 0, 234, 234, 234. So the number occurring at 234, we still start with less, n equals to 0.0234, 234 and so on. 10n will be equivalent to 0.234234 and so on. This is the first equation, this is the second equation. Then 1000n means here 1, 2, 3, 4. They will become 234.234 and so on. This is equation number 3. Now 3 minus with 2. 1000n minus 10n, I still have 990n equals to 234. And n equals to 234 over 990. Make it into simplest form. It will become, please take out your calculator and try 12117 over 117 over 495. So this is the simplest form. Equation 12.645, 645 and so on. Okay, now we can still using the same method. First one, okay, first let n equals to 12.645, 645 and so on, and 100 and 1000n equals to 12645.645 and so on. Then 1000n minus n equivalent to 12645.645 minus 12.645 and so on. So you are going to have 3, 4 minus 1, 3, 12633, 12633, 12633. So 999n equals to 12633, n equals to 12633 over 999, or you can write it as 12 over 215 over 333. This is the simplest form. Okay, so actually from the textbook, there are another method. You can try to refer it. Another method to find the recurring decimal. So I'm going to introduce here, and then during the examination you can choose which method you are going to use. Actually they are similar method. Okay, from the textbook it will be like this. We still use substitution. This number, let's say A equals a number 12.645645, and separate it become 12 plus 0.645645 and so on. And this is a recurring decimal, so I use it as n. So lex n equals to 0.645645 and so on. This is equation number 1. Multiply the whole equation with 1000, it will become 645.645 and so on, equation number 2. And 2 minus 1, 999n equals to 645, and n equals to 645 over 999. Simplify it, they will become 215 over 333. And we put it back to A. A equals to 12 plus 215 over 333, and finally we still having the same answer. Okay, that's all for today.